Introducing a new system where we can take styrofoam and reduce it in size, then send it through an application or a process that turns it back into styrofoam again. Something that everybody's chemistry teacher said couldn't be done. We're doing it now today. This machine takes big chunks of styrofoam and grinds them up, ending up with small particles of styrofoam. From here, at the same time, the machine will spray it with a chemical compound we call StyroSolve, and it begins the dissolving process. And I'll show you how it will dissolve the styrofoam in even larger pieces than this, if you want to follow me this way. All right, what we're doing is we're going to take a little larger pieces of styrofoam, and we're going to kind of simulate what's going on inside that machine. This is a product we call StyroSolve. It's 100% biodegradable and it's 100% reusable. It has the capability of releasing all of the gases that are in polystyrene. What it's doing is combining the polystyrene chemical with our catalyst, StyroSolve, so that eventually, if I put enough of this styrofoam into this beaker, you would have a gel, which would be made up of 1 part StyroSolve and 1 part of styrofoam or polystyrene. And as we continue here, and what's interesting is everybody thinks of polystyrene is or styrofoam is that stuff that you use in packaging, you know, noodles. And but actually, if you look at a TV set that's in your house, the case, the housing, is probably polystyrene, but not expanded. This happens to be expanded, injected with carbon dioxide. What we're able to do with this catalyst is remove approximately 90% of the space or the volume of the polystyrene. By reducing the polystyrene by 90%, or the volume of polystyrene by 90%, what this will do is, if we were to take it and just not send it through our extrusion process, but just throw it away into a landfill, it would still increase the usable land in a landfill by 90% of all the polystyrene. And polystyrene represents about 30% of what's disposed of today in our landfill. What we can do is take a 10-pound block of polystyrene, which is about 10-pound block of polystyrene would probably be twice the size of that cabinet, and we can reduce it. What we're doing is now you can see that the majority of the styrofoam has been formed a gel, a combination between our StyroSolve and the polystyrene. Most of the air is been removed from the polystyrene, and we have a gel left over. Now this gel, I have to use something that is not used in the process to separate the two. If I mix alcohol into here, the StyroSolve, our patented product, will bond to the alcohol, leaving only the polystyrene in its original natural form. Let me pour this in here. and you'll see that what's left is plastic. Pretty cool, huh? So now in our plants, we take obviously not with the alcohol, but that polygel that we just poured the alcohol into. We would send this through a process where the StyroSolve is flashed off with heat, and it would be then recaptured in a distillation process, and the raw material that was left, this stuff, would go through an extrusion machine, and at the other end would come out pellets that could be reused to make more styrofoam or more camera cases or more televisions. So that's our product. Going to save the universe. This is the end result of the this is what comes out of our extruder. It's almost virgin material for the making of polystyrene, and this is pretty much what our competition does. They have to use a process that burns off or actually burns or melts the polystyrene, causing the polystyrene to turn brown. There's limited uses for this kind of product, so it gets a lot cheaper price out on the marketplace, where this, near virgin, gets the highest possible price out there in the marketplace.